Example number 2, related rates. I have a man walking away from a light pole. The light pole is 12 feet high. The man is 5 feet high. He is currently 10 feet away from the light pole and walking at a rate of 4 feet per second. What I'd like to know is how fast his shadow is moving. So as he walks away, if he was continuing to walk away, what you would notice is the angle from the light making the shadow would get larger and larger as he continues to walk away. So down the road, this is what would happen. And notice, he walked a little bit down the road. His shadow, however, moved away further than he did, which means you can't assume that his shadow is moving at the same speed that the man is. So let's back up. And let's begin to address this situation. Now, what we've got is several things moving here. So the shadow's length from the wall is unknown currently, and I will go ahead and represent that graphically. But let me make it a little further down as distance A. So A is how far the shadow is from the wall, and we're looking how fast the shadow is moving away, which would actually be dA dt. So this is what we're looking for. So I need to find an equation of A that relates to the given information that he's 10 feet away and moving at 4 feet per second. So in this case, I'm going to use some trigonometry or geometry, depending on how you want to look at it. And I'm going to label some other pieces of the graph. The distance he is from the wall is currently 10 feet, but since he's moving, we really need to represent that with a variable, and I will call that variable v. And the distance from him to his shadow, which is this distance at the end of the shadow, I will represent with the variable c. So we know what B is at that moment in time. He's 10 feet, but again, it's changing. So how do I set this situation up? A few things. Here's what I know right now, that A equals B plus C. And I know dB dt because he is moving. B is how far away he is from the shadow, from the light bulb, and he's moving at 4 feet per second away from the light bulb. Problem is, I don't know what C is just yet. So how can we figure that out? Well, if you'll notice, I'm gonna make a little triangle here. This is a triangle in green made by the man and his shadow, and that's inside the larger triangle made between the light pole and the ground. So I've got two triangles. They have the same angle where the light meets the ground on his shadow. Same triangle there. So I'm going to use my similar triangles, or I can also use the trigonometric identity called the tangent. In that case, the tangent of both, and that's my little angle here, theta, the tangent of theta gives me 12 over A. It also gives me 5 over C. I can cross multiply this, and I get 12C equals 5A. And what I really want to do is get rid of the C in this equation, because we know how B is working, and we know dB dt. So what I will do is solve this equation for C by dividing both sides by 12. Now, Watch what I've accomplished here. Taking that up and doing a substitution. And you'll find you'll be doing a lot of substitutions. I end up with A equals B plus C. I'm going to go ahead and take this equation and solve it for A. I'm going to subtract 5/12 from both sides. So I have 1 minus 5/12 is 7/12. A equals B. And I can also write that if I want to solve for A equals 12/7 B. Now, notice when I take the derivative of this formula with respect to time, I get the change in A over the change in time equals 12/7 times, when I take the derivative of this, is just 12/7 times, but again, use substitution or chain rule, dB dt. And we know how fast the distance from the light pole the man is moving with respect to time. So, in this case, dA dt is going to equal 12/7 times 4 feet per second. And we can leave it as that fraction because it's not a reducible fraction. 48/7, which is just under 7. It's like 6.9 something. Let's go ahead and, if we want to calculate that, we can. Real quickly. Not clear. 48 divided by 7 is approximately 6.8, what was it? 6 feet per second. So let's review what we did real quickly here. I started out with a formula that had 3 variables, A, B, and C. I used another formula from my similar triangles, or the tangent of my theta there, to set up my second equation. The second equation in red allowed me to solve for C and do the substitution. And that is a key step with many of the problems. Substituting gave me from 3 variables to 2, and now my 2 variables that I'm interested in, A and B, are related to each other, and I can take their derivative and their rates will be related.